Okay, so we get into the topic of regression today, and what regression is, or the basic idea behind it, is that I want to be able to take existing data, create a model from it, and then after that, use the model to make predictions about data in the future. Okay? So I have here data. One column I have all the years since 1950, the other column all the gas prices since 1950, and I want to draw a scatter plot of the cost of gas, y, as a function of years since 1950. And in this assignment, or this video, the calculator is actually going to do most of the work for me. So I'll turn it on, go into Stat, Edit, and I'm going to use List 1 to put all the price. I'll put all the years. So I'm going to clear it out. List 1, go to List 2. I'm going to clear that as well because I want to enter all of the years. I'm sorry, all the prices for this. So in List 1, I'm just going to type 1950, 1960, and just go all the way down. Okay, so I've got all the years entered. I'm just going to go over to the other column and type in all the prices, 0.2, 0.64, and go all the way down the list here. Okay, so I've got all of my prices entered in now. Make this just a little bit darker. Okay, and then I'm going to use my calculator stat plot function to make this happen. So hit second, stat plot, or y equals. We're going to use plot 1 for this in this scenario, and your calculator actually lets you plot a bunch of different things, but I'm going to turn this one on. Make sure the X list is L1 because L1 contains all the values for the years, and the Y list contains all the values for the prices. So we're graphing Y as a function of X, or prices as a function of years. Okay, so make sure all of that is turned on. I'm okay with using this square here as my mark. And then I need to set my window. And in my window here, I know the year is going to go from 1950 to 2010. Oh, but wait a minute. Let's look back here again. It says graph y as a function of years since 1950. So I need to go back into my list and I need to update this because I want it to say since 1950. So 1950 should be year 0. That's my starting point. So for my list, your calculator has this really nice function, this nice feature called list arithmetic. So I'm going to hit second, number 1, or list 1, minus 1950. And it automatically does the subtraction for me. So 0 now is my starting point, that's 1950, going all the way up to 60, which is 2010. Okay? Now I can go back to my window and I make sure that and make sure that I graph it correctly. And you can see that it's just a little bit easier and better to work and graph using smaller numbers. So my X-min, I'm actually going to go from -5. These are the years. It goes up to 60 years on the list, but I'm going to go a little bit above that just so I can get a better view of the window. For the Y-min, I think -0.5 is pretty good. Y-max, and remember Y represents the dollar values. So at the rate of gas prices right now, maybe $4.50 is pretty good. And then 0.5 as my Y scale, and then hit graph. And then you can see the graph come up, and it's a pretty nice looking graph. And so I'm going to pause a minute and then just transfer this on. Okay, so I've transferred everything onto my paper. Notice I've labeled the axes, years since 1950, starting at 0 and going by tens, and then the y-axis, cost of gas in dollars per gallon. So let's look at what Part B says. Part B says find a regression equation and round coefficients to the nearest thousandth. Okay, so regression basically means, again, using existing data to write an equation. And the first thing we have to do is determine what type of equation are we writing, what type of function. And so looking at these dots, they look like they're going to follow a straight line, a linear equation, or y equals x in one of your parent functions. Okay, so there's a bunch of other different regressions, quadratic, cubic, and all that other stuff. But this looks pretty much like it's going to be a straight line. So I'm going to use a linear regression for Part B. And to do that on a calculator, let me bring this back in here. Second, quit out of everything. We're going to hit Stat, go over to Calc, And if you see down the menu, there's a bunch of different regression. If this graph looks like quadratic, I would use quad reg. If it looks like a cubic function, I would use cubic reg, so on and so forth. And there's a long list of different regressions that I can use. Okay. Now in this case, I'm working with linear regression, or ax plus b, a being the slope and b is the y-intercept. Okay. And the two arguments that I need to enter in here are first the list. And I'm using list 1 here because that's all the x values. List 2, these are all the y values, or all the values on the vertical axis. Hit enter, and that's what I get. Okay. And I'm going to write this down here. So I'm rounding this to the nearest thousandth. So y equals ax plus b. And a is approximately 0.040. B is approximately 0.235. Okay, so my final equation is y equals 0.04 x plus 0.235. Okay, so let me slide that up there. We can see a little bit better. Then for part C, it says compare the price of gas in 2000 from your equation versus the actual price. So the actual price in 2000 was $2.20, and let's see what the equation says. Okay, so this is a test of how good the equation is. If the equation is good and a good measure, the number should come in pretty close. Okay, and this, we're talking about year 2000. And remember, this equation here, we're working with years since 1950. So when I'm not going to enter in 2000, I'm going to enter in 50, because that's how many years there has been since 1950. Okay. So y equals 0.04 times 50 plus 0.235. And that gives me y is about $2 or 2.235. So about $2.23. And if we compare the two of them, the actual price is about $2.20. The price from my equation is about $2.23, so it's pretty good. It's only a few pennies off. Okay, so it's a pretty good measure of the graph. And actually, let me show you on the calculator just how powerful this can be. So what I'm going to do is actually graph the function and the equation at the same time, the scatter plot and the equation. So I'm going to type in 0.04x plus 0.235, okay, and graph. Okay. And so there you go. You can see that the line of regression here is pretty close to the data. It's almost through every single point. It's not perfect. There's a point here that's a little bit off, okay, but I mean, nothing in the real world is going to be matched up perfectly to the existing data, to the model that we've made. Okay. So the last question that I need to answer here is, use your equation to predict the price of gas in 2015. So in part C, we sort of verified it with the existing data. So we know the formula is pretty good. So what is the price in 2015? And remember, the year 2015 has been 55 years since 1950. So let's enter that in. Y equals 0.04 times 55. I'm sorry, not 55, 65. So 65 years. Okay. Right. Yep. Plus 0.235. So enter in all those values, and I'm going to get about $2.83, 2.835. So y is approximately, and we're around to the nearest penny here, 2.84. Okay. So based on my model here, it says that I'm going to get a price that's about $2.84 a gallon based on the model in the year 2015. Since this being 2012, we know the price is already way above that because of other factors in the economy. But as far as what we knew from 2010, we would have expected it to reach this point. Okay. And there you have it. So to a quick recap, regression, we use our existing data. Okay. We make a nice graph out of it. Then we use that graph and regression so that we can make a nice formula or equation that models it. We can even graph the model and the scatter plot at the same time. Okay. And then we use the model here to make predictions about the future. This is the price of gas in 2000 and the price of gas in 2015.